problems with the recording. This happened a little bit over the summer too, where it would just the screen share stuff would cut out, and it would just be basically my my video, which I can turn on here in a second. So if you do notice that, let me know. I did play around with it a little bit so that hopefully some of the settings will make it so that doesn't happen in the future. But if it does, definitely let me know if the screen share part cuts out at some point during the actual recordings if you end up watching those. Okay, today we're going to sort of finish up some of the stuff that we left off with last time. So that's getting the spawner going, and then messing around with things like collision. So we can actually have these fireballs we spawn actually collide with stuff. So a little bit of sort of what we skipped last time, and then a little bit more stuff on top of that. I did want to mention, and I'm going to flip over to Blackboard here real quick. GDD1 is available to do, so you have a week to do that. The PDF itself, it's not very expansive. It's just getting a little bit of practice writing a game design document based on the theme that I give you in here. So take the Volcano Island one, or the Diablo one, or the Grand Theft Auto one. Take those, sort of look at them, and sort of follow sort of what they do. The Volcano Island one we talked about last time is very simple. It has notes throughout the document, so you can sort of use that as a starting place. I want you to write this document as if it's for a short game jam style game that you want to make. So work with your group. There only needs to be one per group. Feature-wise, focus on what you think you can reasonably accomplish in that short amount of time. The grade itself is largely going to be sort of based on including the required pieces of the GDD, that sort of stuff. I look at the quality of the writing a little bit as well, and I'll sort of comment on the scope of the game. The theme for this game design document is an unconventional weapon, and you can take that in any way that you want to. It doesn't, you might be able to think of some initial sort of games that maybe this would make something cool, but think about it, come up with a couple of ideas, pick one to write out to expand a little bit. Write out some of the stuff related to the mechanics that might happen, and maybe a little bit about some art style. You don't have to create any art for this at all. If you want to prototype some piece of graphic, that's perfectly fine. But you don't have to come up with any art if you don't want to. I just want to see some sort of idea that you sort of flesh out a little bit more, so that if you were to have to do a game jam on that game, you could reasonably have an idea of what you're going to do. So take the Volcano Island one, take that as sort of a template. Look over some of the other ones that are on Blackboard as well. Potentially, you can find stuff elsewhere too on the internet related to it, and come up with something. It doesn't have to be super detailed, but I do want to see something where I can sort of understand what the game is. I can understand what the mechanics are going to sort of require from the player. That sort of stuff. So theme, unconventional weapon, work with your group, and have this turned in next week. Next Thursday, I think, is when I set the actual day. All right, so Kevin, did you get the player stuff? Let me open up this stuff here again. Okay.
So I have a quick question. So when do we kind of, I know we're talking X and Y here, but in the previous one with 3D, we talked about Z.
Yep.
Do we ever have to manipulate for crashes, and let's say the fireball hits the snowman, do they have to be on the same Z axis for them to hit, or is
So when we talk about the collision stuff, we're actually going to use a 2D collider. So it's actually only going to look at the X and Y, which is nice because if you remember from last time, we moved. If I switch to a 3D view, we moved the head so it looks like this. so that we actually sort of can see the stuff in the correct order. There are other ways to change the ordering to sort of see what stuff is on top of what other stuff, but we actually changed the Z order here. When we put in a 2D collider, it only considers X and Y with the collision, which is going to be quite nice. So in a 3D game, you're definitely going to have to worry about all three axes, but for a 2D game, provided we use a 2D collider, then we won't have to worry about it.
Awesome, thanks.
Yep.
Okay.
All right, Kevin, you good?
Yeah.
All right, so let's head over to the slides. So I basically threw in the slides that we weren't able to go over last time into here. And really the spawner is going to be responsible for a couple of things. I did create an array. So this is the sort of standard array creation, but I made it public here. So we're going to actually see it in the inspector, because I wanted to show you what this looks like, what an array looks like if you have it in the inspector. So you'll be able to see sort of how it works. I think it's useful to see that. This array does not actually hold the enemies that have been spawned. It actually going to hold the prefabs. So we'll talk about that in just a few minutes. Let me make this full screen as well. All right, then we have a few variables. These are pretty standard variables for sort of timing stuff. So things like time between spawns. I also have a variable for minimum time between spawns, decrease amount, spawn timer, and then in the start method, so the method that runs when the object gets created. So in this case, when the game first starts, we're going to set the spawn timer to 0. We're going to use a couple of these variables to deal with sort of a difficulty. So as time goes on in our game, the time between spawns is going to get smaller and smaller. So this is, in other words, our obstacles, our fireballs, are going to spawn faster and faster. The array of enemy objects is going to be what we pick from. This allows us to add a little bit, maybe a variation. If I have multiple different looking fireballs, I could potentially randomly pick one of the different sprites to spawn as the fireball. So we can sort of talk about that. For now, we're only going to have one, but I'll show you how that would work if we wanted to have potentially more than one. So we need to make a spawner script, and I'm going to make a empty game object that I'm going to call spawner that we're going to add the script to. So in Unity, I'm going to right click in my hierarchy. I'm going to say create empty, and I'm going to call it spawner. So that's what I'm going to attach my script to. I'm going to create a new script as well in my scripts folder called spawner. So I'll create that, and then I'll click it and drag it up to, after it compiles here, I'll click it and drag it up to the spawner. So my spawner object now has the spawner script attached to it. So let's go ahead and hop into the spawner script. And
sorry, Professor, did you create an empty, or was it a 2D object or 3D object?
No, I just created an empty.
All right, thank you.
So let me just a second. Make sure I have all of the stuff set up in my second monitor. Okay. Just making sure I had on my group chat and all that stuff. Okay. So let's create a public object, that public game object array, and it's going to be called enemies. And it would be better to call this something like enemy prefabs or something like that, but I'll just keep it as enemies. I'm not going to assign it. I'm not going to allocate anything. There's nothing like that happening here. It's just public array of game objects called enemies. And then I'm going to have a bunch of timing variables. So these are going to be my timing variables. Some of them will be public. One of them is going to be private. So these are all going to be accessible via the inspector. So we'll make a float called time between spawns. And again, I'm not going to set them to anything. We will do that in the inspector itself. We'll make another public float called min spawn time. Another one called, I think it was decrease amount. So just decrease AMT. And then we'll have the private variable for float called spawn. I think I named it timer. In start, and this was on that panel in the slides, that's where I set, because spawn timer is private, it's not going to be in the inspector, so I should give it a value. I could give it a value when I initialize it, but I'll just do it in start. So spawn timer is going to equal 0. It is a float, so I'm going to put 0f. So getting some of my variables ready for the class. The big thing here, most of them are public. One of them is private. The spawn timer will actually be our timer itself. It's just going to continue to count so we spawn something, and then we'll reset it back to 0, so it continues to count up, and then we spawn and count up and we spawn. So this is basically our sort of timer itself, our counter for when we're going to spawn in certain situations when it reaches certain values. So yeah, so again, new object, attach the spawner script to it. All right, so this is the actual spawning script here. I'm going to talk about it. I got some pop-ups and whatnot that show up, but in essence, it's all in update. So every single frame, this is going to be checking, and ultimately it's just an if-else. If the spawn timer is less than or equal to 0, then we do a bunch of spawning stuff. Otherwise, we decrease the value of the spawn timer by time.delta time. So I guess really this is doing sort of the opposite of what I just mentioned. It's starting at some number and then counting down to 0, and then it'll get reset to that number, count down to 0, spawn, count down to 0. So that's in essence that's what it's doing. All the rest of this is just dealing with some of the spawning itself, and we'll go over each piece of that here in just a second. So in my script here, in update, this is where we have that if-else. So again, in essence, it's just a single if-else like this. So our if is just if spawn timer. If that is less than or equal to 0, then we're going to do the spawning stuff. Otherwise, we take the spawn timer and we subtract time.delta time. Essentially, how much time has passed between this frame and the previous frame. So that'll be, whatever. If I'm running at 60 frames a second, every single time this updates, it will subtract 16 milliseconds off of my spawn timer. The fact that I have this start at 0 means that the very first frame of the game, there will be a spawn. If I wanted to set this to something so it doesn't spawn right away on the first frame, I'd need to change this value to something else. And you can think of this in terms of seconds. The unit for this is seconds, because time.delta time is also in, and it's also, you can think of it as also being in seconds as well. Right, so the rest of this, then there's a few pieces here. We're going to grab an enemy prefab. We made a prefab last time. That prefab is going to be contained in the enemy's array. So we're going to need to put it in there, and we'll do that in a second. But all I'm doing is saying pick a random enemy from that enemy array. And that enemy's array will be just one of the prefabs. If we only have one enemy in there, then this is going to give me a random range between 0 and exclusive of length. So it's just going to pick one single enemy. But this is where you could add potentially more enemy variation by putting more enemies into the array itself. So I'll show you that in a second. And then the float location. This is the X location that I'm going to spawn the enemies in. I'm going to do a random range between two values. So I'll show you how we can think about what those values should be. Here I just put -5 to 5, but that might be different depending on the aspect ratio of your game, for instance. You might need extra logic to figure out what that is. We're just going to hard code it right now, but potentially you could put it in a variable or something as well in the inspector and be able to use it that way. So let's go and look at that enemies array and think about what the range of our spawn should be. So in my main game here, in my scene, this box here, because I'm going to see me highlighting on the camera, this box here is what the camera sees. So if I want to be able to spawn from one edge to the other, then my spawn range needs to be from here to here. So that's what that location is looking at. If I want to know where that is, I suppose an easy way would just be to move my, let's move the player instead over around. So let's move the player. So I can move the player over like this, and the player here is at about 8. And I look over here, and the player's at about, I don't know, somewhere around sort of -9, -8 ish. So I could use that to figure out sort of where the edges of this actually are. So this is something that you can mess around with. We should probably have this be a variable somewhere along the way, but for a simple game like this, we're just going to look at the value and sort of hard code it in. And I can probably move the camera a little bit. Let me actually zero out some of this X and Y here. That's probably better. So if I move the character again, I see, yeah, just about 9 to -9, maybe -8, 8 to -8, something like that. So that's going to be what I use for the sort of the spawn between. I'm going to spawn between -9 in the X and 9 in the X. As far as the spawner goes, here is this enemy's array. It's just a dropdown. Right now, the size is 0. There's no elements. But I can change the size to 1. So now here we go, element 0. It's supposed to be a game object because that's what this array is of. It's of game objects. So I can go to my prefab folder. We made a prefab before. Let's grab our enemy prefab and drag it into element 0. So now that array, even though in code I don't do anything with it at all, now it is size 1 and it contains an enemy prefab. And if I had a second enemy prefab, maybe slightly different graphics or something, or maybe a different particle effect associated with it, just a second prefab of some sort, I could make the size of this 2, and I could throw in a different version. Now here it sort of it keeps that enemy prefab I already put in. But if I had another prefab to use, I could throw that in here as well, and then I could get a little bit of variation on the enemies that actually spawn. And the prefab itself, remember, contains all the information about the enemy. So if I open my prefab, we can see, okay, it does a certain amount of damage. It has a min speed and a max speed. Potentially, if I had a different type of enemy in the game, maybe it did more damage, maybe it moved faster, I could also throw that one in. And then randomly, because in code, I'm going to randomly select one of those prefabs from my array, then I could have multiple enemy types spawning at random. So that's the idea of using sort of multiple prefabs to create some sort of randomness in your game, which can be quite useful. And then, of course, making prefabs so that it makes it easy to create them. We just throw them in here. So I'm going to make this just size 1. So that we only have sort of one enemy at the moment. Potentially later on, we could go in and add another enemy type. I did have a couple of extra sprites here for different enemies. So the fireball I chose was this one, but I had some other sort of a little bit more stylized ones as well that we could throw in as other types of enemy fireballs. So up to spawner. Let's set some of these values. This is something we can tweak. So something like time between spawns. Maybe we want 2 seconds between spawns. That would be the initial time between spawns. The minimum spawn time, maybe I want that to be 1 second. So the fastest these spawns get are 1 every single second. Then the decrease amount, so every single time there's a spawn, we will decrease the amount of time between spawns. So maybe every single time we decrease by 1/10 of a second or something. So maybe we'll try these settings. We can always go in and change them. There's nothing stopping us from doing that. We'll tweak it to whatever our heart's content to make the game play as good as possible. So that's one of the nice things about using the inspector. I don't have to go back to code to mess around with some of these settings. So let's go back into to the spawner and let's actually code that spawner stuff up. So I'm going to grab a game object, and this is going to be the enemy that's going to spawn. So that's what I'm just going to call enemy. And this is going to be randomly selected from that array. Now, the array is only 1 element in size at the moment, so it's only going to ever select that one. But if we add more, let's sort of add that capability in. So I take my enemies array, and the element I'm picking is going to be random range. And in this case, it's going to be integers. So there's a few overloads for this. We can put in 0, and it's going to be inclusive for the min, exclusive for the max. So similar to maybe other random number generators you've used in the past, like in Java. And so here we'll put enemies.length. So right now, the enemies.length is 1, but it's exclusive of 1. So it's just range 0 to 0. So it's always going to pick that one enemy prefab that I put in the array. the location, this would be maybe I'll call this like the X location, like the X spawn location. That's going to be just a random value. So again, another random range, another random dot range between, let's say -8 and 8, and these are going to be floats here. So on the X location, and this should be a float as well. So on the X somewhere, we're going to spawn between the X of -8 and 8, which is what we sort of looked at in the actual scene itself. So we have the enemy prefab we want to spawn, should be this here, and we have the X location to spawn it. The way to spawn any object is to use instantiate. So instantiate, essentially, you take this object, whatever object you want to make a copy of. That's going to be enemy. That's our enemy that we picked out. That's our prefab that we want to create. The next argument is the position, and this has to be a vector 3. So typically, you write something like new vector 3. This is going to be X, Y, and Z. So the X location we already computed. X location. The Y needs to be how high we want this to spawn in our scene. So if I take my player and I move him up in the Y, the very top up here is around 5-ish. Around 5. So if we spawn this object, maybe say around 6 in the Y, it'll spawn above my screen region and it'll fall down basically through the whole region and then out the bottom. So I want to spawn this at around 6. Again, you probably want to make this a variable to change in the inspector, but since we're not messing with the camera at all in this game, we can just leave these as hard-coded. So we're going to say 6F float, and for the Z, let's just put 0 for now. We can see where this, we can see sort of what overlapping stuff happens. If we sort of overlap some of the sprites, maybe somebody's going to be in front of or behind, and we may not like that, so we may adjust that later. There's one last argument here. It's essentially rotation. For our fireball, it's not really going to matter. Most of the time, you don't have to worry about this too much, but it's in terms of a quaternion. A quaternion is more or less a 3D representation of a rotation, and they're a bit tricky to understand. Unity has some niceties to make this easier on you, so it can turn Euler angles into a quaternion. So what you would normally think of as a rotation angle, it can automatically turn that into a quaternion for you with some extra functions. For now, I'm going to use a very simple quaternion. Quaternion.identity. All that does is it keeps the same rotation that you see if you just drag the sprite into the scene itself. Because our fireball in this case is a circle, it doesn't matter. But in other cases, you may want to spawn something rotated in a particular way, in which case you may have to mess with the quaternion stuff. And we will mess with that more later on in the semester. We'll mess with quaternions a little bit more. So this is how the instantiation happens. We got a couple of extra things to do. We're going to run the game first, like this, without putting in the decreasing time stuff, but there's one more piece that I need first. This is taking the spawn timer and setting it back to time between spawns. So we drop down to 0 because of the else, we spawn, and then we bring it back up to whatever value it was, 2 seconds or whatever. So that's your basic spawn. The enemies here are going to spawn every 2 seconds, or whatever value we set in the inspector. So I'm going to save that and go back to Unity, and we're going to run. And there's one, and we should see more. So every 2 seconds or so, this is going to spawn. I should probably make this a little bit smaller, but every 2 seconds, we're going to get a random spawn location. Now, if I go back to the scene view, notice that they never despawn. They just keep falling. So I'm just going to get more and more of these. And in the hierarchy, notice it's called enemy clone. So every time one spawns, I get a new object showing up in my hierarchy, and they never go away. This could cause a problem. My computer's good enough to handle many of these. But if I got to thousands, tens of thousands, hundreds of thousands of these and never got rid of them, then your computer's going to start to chug a bit. So that's something you want to keep an eye on. Make sure that if you're not using something anymore, like the object moving, say, past the bottom of my screen, that you either get rid of it or you use a design pattern called an object pool, which is something that we probably won't worry too much about, but there's a good example of the object pool in the game programming patterns book that I mentioned a few times. And notice they do have different speeds. So this one here is much faster than some of these other ones. So it is getting a random speed when we spawn, because looking at the prefab, we set a speed, min speed 1, max speed 3. So when the object spawns, the code that we wrote for enemy, let's go back to my scripts, the code that we wrote for my enemy actually runs. So as soon as we instantiate the object, the start is going to run, and it's going to pick a random speed for this object to translate down at. So that's the idea here of getting some stuff spawning. Let's throw in the extra piece here to decrease the spawn time. So this is just going to be we're going to take time between spawns, so that variable that we chose, and we're going to do a minus equal, and we're going to use the decrease amount. So every time something spawns, the next time something spawns is a little bit shorter. And we need an if statement to say if time between spawns, if that goes less than my minimum spawn time, so the time that I say is the fastest it should go, then just set it to the min spawn time. So it's just making sure we don't go faster than the minimum time that we allow. So now it'll start at 2 seconds, and every time something spawns, it'll be a tenth of a second faster for the next thing until we're spawning every second. So that's not something that's 100% needed, but I wanted to show something like that you can mess with these variables and sort of think about increasing the difficulty. And you might have a function in here that does that. You might have a function that says increase difficulty, and it does this piece, which would probably be useful, because then you could increase the difficulty sort of at any time you want to for any reason. But for now, this will work just fine. Okay, so let me go back over to the slides here. So here's that full thing again inside of the spawner. So does anyone have any questions on the spawner script, the spawning stuff so far?
Yeah, my computer kind of crashed, so I kind of joined it recently. So could you possibly click on the spawner in the hierarchy so I can kind of see what you got on the right, because it's not really printing out what.
So yeah, so it's
Dude,
so
you
it's,
got 2, 1.
yeah. So I've got for the time between spawns, I got 2. Min spawn time is 1. So the units on these would be seconds, and the decrease amount is 0.1. So 0.1 seconds less each time you spawn, and then I have that the enemies array that I put the prefab into. If we didn't have anything in here, so if this was just empty, then I would get essentially a null pointer, or like a null reference exception, saying that you're trying to instantiate something that is just null, and so that would cause a problem for sure.
Sadly, I'm not seeing anything. It might be my Z value. It's printing out a bunch of different, like, in the hierarchy, just a bunch of different, like, clones. It just keeps printing them out.
So you can definitely check whenever the clones pop up.
Yeah.
If you do click on one, you can see their position. So this clone that I have here, it's X position. It's not changing it at any point because I'm not moving in the X. You can tell it's moving in the Y, so it's going downwards. So you can definitely check on these. If you want to also see what's going on, where you can sort of zoom around, you can go back to the scene view, and you can zoom out, and you can pan and do all that stuff as well, so I can sort of see everything that's going on. And we can always mess around with it as well when we finish up class if you're not able to figure it out.
Yeah, I think I just got the main camera kind of.
Yeah, you can always move for main camera. You definitely want to change the position probably to X, Y being 0. Z doesn't really matter, but it shouldn't be too close to 0. Maybe like a -10 or something like that. There is clipping stuff. There's a near clipping plane and a far clipping plane, and there's sort of the 3D sort of stuff related to it. So typically, like a -10 is sort of a good value for the camera in this case. So
Okay. Yeah, I don't know why. I just don't see any of the fireballs in the screen for some reason.
To go to the scene view, Johnny, up here so whenever you press play, it will switch to the game view. It should be a tab in
Uh,
depending on how you have stuff set up. There should be a tab in the same place. So you see like
yep.
asset store here. There should be scene. So you can click. So if you click on the scene, then you can mess around with all the scene view stuff associated with this.
So I actually found it. They're not falling is the issue.
They're spawning above,
Yep.
but not moving. Yep. So take a look at the enemy script and make sure that you have the sort of translate stuff set up, and potentially in the enemy prefab, make sure there's a non-zero speed, for instance. Like you didn't pick like if you just left 0 and 0 for min and max speed, then the speed would be 0, then it wouldn't move at all. So things like that.
Okay.
So yeah, so definitely check the enemy prefab. In my prefab folder, I can just click on the prefab and you should be able to see the stuff from the enemy script. And you can also open the prefab sort of separately.
So the speed. So I have to change the speed is why.
So the min speed and the max speed should be some value.
Gotcha. Okay, now I see them falling. Great.
Good.
Thank you.
Okay, so most of the sort of pop-up stuff here is just things that I mentioned, things like instantiate takes a game object, a position, and a quaternion, which in our case, again, it's identity, which is equivalent to 1. So it's not going to rotate it from sort of whatever orientation it is in our sprite. After each despawn, or after each spawn, we decrease the time until it gets to a minimum value, and then we reset the spawn timer. So that's our spawning script. So what we still need to do for today is collision for the snowman and the enemies. So we want to make sure that we can collide with the snowman itself, with the ground, with walls, so we can't move our snowman off the edge of the scene, and with each other. So obviously the snowman and the fireball should hit each other. We'll code up a little damage system. We don't have any way to really display it right now, and there's no sort of death stuff that we're really going to worry about for the moment. We just want to make sure we can get some of these things in. And then we'll look at a simple way to sort of reset the game. So let's say the user wants to play again. We want to make sure that if they do play again, everything gets reset back to some original sort of situation. Things like particle effects, animations, sounds, an intro, maybe game over screen, those are on the list too. But we're going to work on them after we get the basic mechanics down here. So things like polish, they should take a backseat to a working and hopefully enjoyable game. This game's not going to be that amazing, but in the end, you want to make sure the mechanics feel good before you start really focusing in on the polish. All right, so we got to talk about colliders. So here's a version of the snowman, not quite the same version we have now, and there's that really crappy hat. We're going to put a collider around our snowman, and I think actually in Unity here, I think I already had one in there, so around the snowman. So we'll go ahead and add that in again. I'll delete it when we flip over. They're just another component. So just like the rigid body that we have for the snowman, just like our scripts, they're just another component that we add to our object. They define the shape and potentially some extra parameters that are used to determine if two objects touch. At one of the recent hackathons, and yeah, I think it was just at one of the recent hackathons last year, 2019 fall one. I gave a little talk on sort of using JavaScript to make sort of a dinosaur, one of the like Chrome dinosaur game things. In that one, I just used circles as the collision objects, and essentially you just look to see when do they touch, and when they touch, you do something. So that's all we're going to use here. That's all a collider is. It's just a bounding area. So in this case, for our snowman, we're going to use just a square. If another bounding object, another square of something moving in our scene, touches our snowman, it will either trigger us to do something, like take damage, for instance, if a fireball hits us, or potentially stop us from moving if we try to move outside of the play area, like we try to move left or right beyond the edge of the screen where we add our sort of invisible walls. The math behind these isn't too bad. uh, we could code up the math ourselves, but we are not going to. We are going to let Unity deal with all of the collision stuff. Circles are the easiest collision objects to code yourself. Squares are a little bit more complicated, but not too bad. Other random shapes are potentially very difficult to do. Johnny, why not use 2 circles? You certainly could. In that case, you would probably, let's see, let me think about, because it would still be on the same object, so you would still do a like an on trigger enter or an on collision enter. So it would certainly be, it could certainly be doable, although I'd have to check for sure. Adding 2 colliders to one object, I don't think is going to work properly. So you'd have to add it actually probably to the sprites, which could be a bit of a pain because then you'd have to grab the components, and it would be a little bit more work to do that. But I think you certainly could. Typically, sort of 1 collider per object. Yeah, so something like potentially a capsule collider. Capsule colliders are in the show over here. So in my player, I have a box collider 2D on here. So remove that. So if we look at colliders, we have a whole bunch of colliders. We definitely want to use the 2D version. So a capsule collider, just a regular capsule collider will be 3D. The 2D version is the one you'd want to use. So if we don't want to worry about the Z axis at all, we definitely want to use the 2D ones. There are polygon colliders as well. So if you want to follow something much closer to your image, to your sprite or something, a polygon collider can work as well. Just know that the calculation behind the scenes is going to be more complicated the more complicated the object is. So a circle or a square will be quite simple for doing calculations. A polygon collider, or in 3D it would be a mesh collider, start to become much more difficult in terms of processing power to do. So for our snowman, I'm just going to leave it as a box collider, just for example. What you can see in when I select my object now, when I select player and I've added this box collider 2D, is there's a green square. That's my collider. If I want to edit what this collider looks like, so I need to make it taller to encompass the head of my snowman, there's a button in the box collider 2D area that says edit collider. As soon as I click on it, and it is a bit tough to see here, I might have to zoom in quite a bit. There's little handles that pop up, tiny little squares here, and I can click on it and I can drag it up, so you can see the little squares that pop up. So I click on it and I can drag it and I can move it around, and I can make it smaller, make it larger, whatever I want to do. And then as soon as I click off of my character, then we're back to not editing the collider. So this right now represents my collision region. So if something were to hit right here, for instance, on the screen, it might not look like it was a hit. This can really piss off players. If you've ever played a game where the collision, the box collider, whatever colliders they use, don't look like you actually hit something, it's the colliders hitting, not the actual sprites themselves. So feel free to mess around with any sort of 2D collider you want to. I could throw in that polygon collider, for instance, or a capsule collider. If I do a polygon collider, typically it starts out with some kind of polygon, and then you should be able to start messing with stuff. So it's a little bit more complicated because it gives you this little sliding thing. So I can create more points here like this. So I can drag edges, or I can create more edges to sort of more precisely match what this thing should look like. So something like that might be a little bit better for my snowman. It doesn't have to be super complicated. Gabe, the capsule one, actually, that was a little bit ago. The capsule one will certainly probably work pretty well as well. It doesn't really matter which one you use for our particular case here, for our particular game. You can pick one, mess around with a little bit, mess around with changing the size. It's just going to represent that collision region. So I'll go back to the box collider, edit that shape, and do something kind of like this. If you played sort of long ago the original Flappy Bird, the box colliders, or whatever colliders they used, whether they were circles or boxes or something, they were larger than the actual sprites themselves. So that's one reason why the game was very frustrating to play. So I have my collider. So I should be able to see that whenever I click on my player. So I got the rigid body for movement, for physics, and I have the collider to help me determine when actual collisions have taken place. What we do when a collision has taken place is going to be in code. Unity knows when it takes place, and Unity will call one of our particular functions in just a moment when a collision happens. So if we want to take damage or something like that. So back to the slides here. So yeah, so exactly what happens when objects touch depend on what code you write and other attached components. Potentially, you can sort of have physicsy things happen as well, so you can interact with a rigid body as well to have things like bounce off. We're not going to worry about that for this particular one, but you can interact with other components as well. So again, typically you want to use simple shapes. It makes the behind the scenes calculation ultimately faster. Circle being just a single circle being the sort of fastest one, and then the square sort of not too far behind that. Most games will make the collider smaller than the actual graphic itself, smaller apparently than the actually graphic. It will make them smaller because that just gives a better player experience. You want to make it look like, you want to make sure that the player knows they got hit before you have the collision code actually run, because you don't want to have it look like the fireball was really far away when they got hit. That makes for a bit of a frustrating experience. So it's some of these little tiny tricks that people have learned sort of over the years of making games that, yeah, you probably want to make the collider smaller than the actual sprite itself. So we were messing around with this, add a box collider 2D component, adjust the collider size so you can mess around with it. You get the little handles on it. Make sure the collider is appropriately positioned, and do the same for the enemy. So we're going to go into the enemy prefab and add a collider to it, and I'll probably use a circle collider for them. So back to Unity, I'm going to go to my prefabs and select my enemy. And I am going to open the prefab so I can actually see the graphic associated with it as well. So I open my prefab, and I'm going to add a circle collider 2D. And it actually did a pretty good job here of sort of setting the size of that. The fireball was a little bit large when we were in play mode, so I might want to scale that down a little bit. So maybe I want to have it be about half the size in the X and Y. And the circle collider does scale with that as well, which is nice. So my circle collider looks pretty good. It's a tiny bit smaller than the graphic itself, which is perfectly fine, and I don't really have to mess with it much. If you do want to edit it, you can change the radius. Is sort of the main thing that you mess around with this. So I don't need to do that because it looks like it's just fine. There's some offset stuff you can do as well. The sort of values in here that you mess with when you edit are right here. So the offset and the radius, but this basically looks fine to me. So we've added a collider to our snowman and to our fireball. So what I want to do, remember to get out of this mode, looking at the prefab, up in where the hierarchy is, there's a little arrow that you can press to get back out. So I'm going to save the scene here, and I'm actually going to run it, and let's see what these colliders actually do to each other. So they sort of roll off. There's a little bit of stuff going on there with physics. So it is messing with my physics engine a little bit because I have a rigid body on it. So the rigid body, the colliders sort of cause this push, and then my rigid body starts doing stuff where it ends up with some rotation and some other movement. That's definitely not what we want, but the colliders are definitely working, and that is a good thing. That is something that we want in our program, that the colliders are interacting with each other, even though it's not quite working the way that we want it to. Let's see. We're going to create a couple of new empty game objects as well. I'm going to name one right wall and one left wall. And I'm going to put a box collider 2D on each one of those. So they're just going to be empty. There's not going to be any graphics associated with them. Think of it as the invisible wall so we can't move off of the screen itself. So if I go back into Unity, in my hierarchy, I'm going to create two empties. So we're going to have the right wall, and we're going to create one for the left wall. In principle, I should probably just make one and then copy and paste it, but I'll make them separately. So I have a right wall and a left wall. I'm going to add a component to them. and it's going to be the Box Collider 2D. If you do accidentally make a 3D version, so if you just use Box Collider instead of Box Collider 2D, the 2D and the 3D engines for this do not interact. So a 3D collider can pass right through a 2D collider. So they're not going to interact with each other. So make sure that you use the 2D ones in the 2D situation. Then I'm going to take this object, and I do want to move it to 0, 0, 0, but I'm going to initially take this object and sort of expand it out so it sort of looks like a wall with sort of whatever, some amount of thickness to it. I'm going to move the position of this in the transform to 0, 0, 0, 0, so 3 zeros. And then we're going to take the right wall, and we're going to move it over. So we can grab this guy, move it over. We can use the position stuff here in the transform to do it if we want to, but I'll put it just so it's maybe right near the edge of our screen region like this. So kind of like that. And for the left wall, I don't need to expand it sort of through the whole thing because the snowman's only going to be here in the center. Actually, the snowman will probably be a bit lower, so we might want to make this a little bit lower like this maybe. And then that's basically where I want it. So for the left wall, I'm going to do the same thing. I'll create a box collider.
I'm a little confused.
So for our object, there's a couple ways to move it around so we can sort of visually see it. In the transform, we can actually just hover over the X, Y, or Z. And you can actually just click and drag like this, and it'll move it. The other option to get this sort of axis marker thing here, it's up in the upper left. There's a hand for doing like panning stuff like this, but there's also this direction one here and a rotation and a scale. So if you look at the one that sort of shows up, left, down, right, then it picks this thing up, and we can click the center box and move it around.
Awesome. Thank you.
Yeah, there's a few ways to do it. Gabe, not really in terms of extending the walls up and down, making them larger like this. It's not going to cause any problems. I don't think our enemies spawn this far over. That's the only thing you'd want to make sure of is that this isn't sticking out to the left or right too much, so that the fireballs actually hit the collider. But actually, that'll be less of a problem in just a moment because we're going to change the collider just slightly. But yeah, you can certainly make our sort of invisible wall encompass the entire height of the screen region if you want to. So for the left wall, I'm going to do the same thing. And I will zero that out here in just a second. I should check if there's some setting or something because this is never zero to begin with, which would be nice. So I'm going to move this one over to this side here, stick it a little bit on there. And with these two left and right walls on, they don't have any physics components on them. So if I hit them, it's not going to move them. So if I run this and I come over here, now the physics engine is either going to sort of show maybe a little bit of a bouncing off, and that's a physics engine thing. But for the most part, I can't get anyone closer than this. Again, there might be a little bounce thing that happens, but I can't get any closer to the wall. That's over here. So that's going to be our invisible walls that we make. Just a simple box collider, and of course we have our spinning snowman now. But we're never going to be able to move past the right or left wall. So that's how we keep it on there. Now, there are some caveats to this. We just hard-coded it and put them in. There's no code associated to these. I just made the objects and dragged them to where I wanted. That's fine. It limits our play area. But if we were targeting more platforms, let's say I wanted this to be on iPad and on my phone and on computer, and I wanted to support different resolutions on our computer, that's going to change our aspect ratio. So back in Unity here, if I go to game, in the upper left of the game panel, there is the aspect ratio of your game, 16:9 for this one. That's going to be fine for most people's monitors, but the iPad, for example, is a 4:3. There's a whole bunch of different phones with different various screen sizes for stuff. If I start messing with this, it doesn't change where my walls are. So now my walls are actually outside of the screen region for a 4:3 game, which is what the iPad size would be. So for now, I'm just going to leave it at 16 16:9. So we're just going to have a fixed aspect ratio. But if you wanted this to work for many aspect ratios, you will need scripts that maneuver these walls into the appropriate position based on the size of the camera. In other words, the aspect ratio. So there's a bunch of camera functions and stuff to change the position of the camera and the aspect ratio and sort of have stuff fit and determine where the camera's view is located and all that kind of stuff. We're not going to worry about that right now. We're not going to mess with the camera at all. But keep that in mind. If you want to support multiple platforms, potentially you're going to have to worry about how much of the screen region is being shown. And that goes to things like the size of things as well. If you want some main menu text to take up half of the screen, what does that mean in different aspect ratios? Do you need some code to adjust the scale of your buttons or your sort of title text or whatever it is you're showing? So we will get to some UI where you'll see some stuff that helps with that, but that is something to think about if you don't have a fixed aspect ratio game, if you expect to support multiple platforms. So that's one thing that I did want to mention, because this is you could almost say this is sort of a hacky way, because we just sort of make some assumptions and then say, all right, yeah, this is good, this will work. But for a first game, this is perfectly fine. All right, so we did this for the right wall, for the left wall. We need to do this for the ground as well, because when a fireball hits the ground, maybe we want it to make a little explosion or something. So maybe not as big as if it hits the player, but we want it to sort of explode, maybe disappear, something like that. So let's make a ground collider as well. So in my hierarchy, I'll create another new empty, and I'll call this one ground. And I'll add another component. It'll be my box collider 2D. And I'm going to zero this one out completely. And then we can sort of drag it around, do whatever. Now, our snowman doesn't actually fall to the ground. So I can do something like this, for instance, and so do that. I don't have to make it super thick. But something like this sort of makes sense for a ground. So let's see what our fireballs actually do. The snowman's not going to hit the ground at all. It's actually too high, so we'll probably move the snowman down. But our fireballs, they just keep going, don't they? So that's why we're going to make a change to the fireball. If we go to the scene and we look at the ground, it's still there. The fireballs are all still there, but they're not sort of interacting with it in the way that you might expect. So we are going to mess around with what happens when the fireballs hit the ground. The reason why the snowman is moving around some when it gets hit by the fireballs is because of that rigid body. And that's why we also can't move past a collider like this. So the rigid body and the colliders are very important for each other when you want to make sure that, for example, something can't move past another thing. Otherwise, these objects just appear to be passing through each other. So rigid bodies and colliders are associated very tightly together. So that's something that I do want you to keep in mind. All right, so one last thing for a collider. We're going to open up our enemy prefab, and we're actually going to make the enemy collider a trigger. We don't have to do this. There are other ways that we can mess with this, but we're going to use a trigger for this. In other games, we're going to use triggers and sort of regular colliders as well. This is the only trigger we're going to have in this project is this one. In future games, we will use them a bit more extensively. Triggers just change the code that we're going to write just slightly. So I did want to show off sort of what they do. So in our enemy prefab, we're going to go in and check is trigger in our box collider 2D. So on my prefab here, I can just click on it. Here's the is trigger. I'm going to check that. Now what we'll notice when we play is that if our snowman gets hit by a fireball, so right here, nothing happens. It's almost like it's not there anymore. That's because we've made the enemy a trigger object rather than an actual object that can collide with something like my snowman. Every time a trigger happens, we're going to be able to run a little bit of code. So you can imagine when the fireball interacts with the snowman, even if the fireball is a trigger, it will cause some code to run. And we're going to write that code essentially right now. or in just a moment. I have the player reset stuff here. So let's do the let's do the player reset stuff. We're just going to write a couple of functions. The player is going to have a function called reset that just changes stuff like maybe it changes the health back to 3, which you should probably have as a variable or something in the inspector. Changes the position back to some value 000, for instance, and then sets the game object to active. I'll show you what that does here in just a little bit. So sets the player's health back, sets their position, and then does this set active stuff. So I'll show you what that is right now. So let's go to our player object here. Set active is equivalent to clicking the check mark right next to the object's name. That's just the code way to hit this check mark. This is now not active. You don't see the object in the scene, and it's grayed out in the hierarchy. If I click it back on, now the player and everything is there. So when the player is not active, you can't do anything with it. When it is active, it's just a regular object in the game. So we can ensure that when the player is reset, everything is active. The player is active, the health is restored back to normal, and the player is set back to wherever, the middle of the screen, for instance. So in our code, in our player script, I'm just going to write a separate function, public void reset. There is a reset function that is available through Unity. We're not going to use that one. This is just going to be our own reset function that I'm just going to leave as a lowercase r. So this one, we change the health back to a value of 3. We can create a new value for the position that we want. So I'm just going to create a vector 3. We could do a vector 2, actually. Let's do a vector 2. And I'm going to call it pos for position. We have to create the vector this way. We could do this sort of thing in one line, but I'm going to create the position itself like this. And this is going to be a new vector 3 or a new vector 2 case. And let's just set it to 0 for now. We can always change this later or create a variable or something for it. If you don't include z, it will automatically put it at 0. At least it should. And then we'll say this dot transform dot position equals pos. So we're just changing the position, picking a value, changing the position, and then we're making sure that that check mark for active is on. So this dot object, this dot game object dot set active, and this needs to be true. This dot game object is referring to not the script, but the game object the script is attached to. So whenever you see me write this dot game object, if we go back to Unity, that's referring to player, because otherwise I have this player script. So this can refer to the player script, or potentially using something like finding the components or something. You can say like this dot get component, stuff like that. But if I want to make sure that I can access stuff like the tag, for instance, or other things up here, then I want to say this dot game object. When in doubt, a lot of times you will use this dot game object to do stuff. But specifically, this dot game object will allow me to do the set active check mark on this object. So that's a quick little reset thing. If we call reset, we'll sort of reset the player back to its original sort of starting position with its original health, making sure that it is active. We're going to do the same thing for the spawner. Here I had the time between spawns a little bit shorter, but we want to make sure to reset that as well. So it sort of resets the difficulty. So in the spawner, I'm probably just going to hard code this. There's always sort of other ways to do it as well, but I'm just going to say something like time between spawns equals 2 or something to sort of set that back. So it's just another sort of restart thing that we would have to call. So in our code, in our spawner, I'm just going to write that extra function. So I reset, and we'll say time between spawns equals, we'll just hard code it to 2f. I could always create something extra up here to store what the original time should be, and then set that up correctly. But we'll keep it like this for now. So just a little bit of restart stuff. We're going to use the restart with our game manager once we get there in the future. All right, so here is a little piece of the game manager that we worked on last time, the singleton portion. So this was in the previous lecture. We already wrote the little singleton piece of this. The game manager is going to have code for dealing with the UI. So things like mouse clicks on the menu, like what happened when you click a menu item, that sort of thing. It's going to reset the game. So it will end up being the one that calls those reset functions. And sometimes, depending on how we set it up, it could facilitate communication between classes. So we'll talk more about that a little bit today, depending on if we get through most stuff here. So in our game manager, we need a reference to the player, and we need a reference to the spawner. At the very least, we're going to call reset in start. So player has a reset, spawner has a reset. But just like in any other language, I need a reference to those components in whatever game object they're associated with. I need a player reference. Otherwise, I can't call that function. So hopefully, me sort of saying that, hopefully that makes sense. We have to have a reference. Otherwise, you get something like a null reference exception, where you're trying to do something on a variable that is just null. There's a couple ways that we can do that easily in our code. There are more ways to do it. There's various patterns that let us do stuff easily, but for now, there's going to be two ways that we're going to talk about. There's a find system. The downside to the find system is that it is slow. We're essentially going to find the object that contains player and find the object that contains spawner. We're going to use a tag system, so I'll show you how that looks. But you should never use find, and I have this in a pop-up coming up in one of the upcoming slides. You should never use a find in a method that's running every frame. So running it in start, that should be fine. Running it in update to do a find like this, that's not a good idea. That is a very bad idea. Because it is so slow, it will have a detrimental impact on your game for sure. So in start, I'm going to add this. So as soon as the game starts, as soon as the game object, the game manager gets created, which is at the beginning of the game, I'm going to find the player and find the spawner. So I have references to them. And then I'm going to call reset. So back in my code, let's open up, and actually I'll open it up from here. So scripts, I'm going to open up the game manager. All I have right now is the singleton section right now. So for the rest of the regular class stuff, I'm going to create two variables. I'm going to create a player variable, and I'm going to call it player. And I'm going to create a spawner variable. Call it spawner. These are going to be my variables for holding those references. We can probably make these private. Nothing else is going to need to access them. I will show you another way to do this in just a second where we don't have to use the finds. And then I want to have my start. This was using one of the snippets, so it's just a quick way to make the start. And we can say something like player equals game object. This one has a capital G, so it's just a generic, it's basically the static game object class. So we can do certain things with it. These are things that eventually you'll sort of get used to that, oh, I need to use the game object class to use the find game object method, for instance. So I'll say game object dot, let's see, find game object. We want find game object with tag. And this uses a magic string. So we're going to look at that in a second. And this finds the game object, but we want the player component in that game object. So we need to say get component player, and then we're good. So we're finding the game object that's tagged with player, and we're getting the player component from that to save it into the player variable that we have. I'll do the same thing for the spawner. So this is going to be game object dot find game object with tag, and this will be spawner dot get component spawner. So we're finding something with a tag that represents whatever it is we're going to try to get, and then we'll use the get component on it. We haven't set up any tags yet, so this will not work properly. In fact, if I were to run this after calling player player.reset and spawner.reset, this would give me an error. So let me show you that. Because it won't be able to find a game object with that tag, and so it should give me an error. Ah, that's right. I don't have my game manager actually attached to anything at the moment. So let's add another empty, and I'll call this game manager, and I'm going to attach game manager to it. Now we should have a problem. If this works, then yeah. So we did get an error down here. So this is a no reference exception, object reference not set to instance of an object. Notice the game is still running. The game manager script basically doesn't function the way it's supposed to, but the other scripts are running just fine. So when you get an error, it's not always going to cause your entire program to crash. It could not run that reset stuff that I tried to do. So definitely want to pay attention to your console, especially when you get errors on there, because it might look like stuff is working, but you might be getting errors in certain places. So no reference exception, so it can't find that tagged thing. So in here, if I click on player, there's a tag drop down underneath the name. If you open the project from the stuff that I sort of started you with, you should already see a couple of these tags already. If not, I can show you how to add them. But there is a player tag already, and typically there will be a player tag as a sort of a default tag that sort of comes with sort of every project, already created with every project. So my player itself, I want that to be the player tag. So now it's been tagged as the player. It has a player script, so that find object with tag should now work for me. If I go to the spawner, I can find the spawner tag. This is one that I've created. So let me show you how to create one. You go down here to add tag, and here is a place to add more tags. So this will be empty if you don't have any additional tags created. This will just be empty. You say, yeah, do a plus, and we say my new tag, and you save it. So now it gets added in here. And then I can go back to my spawner, for instance, and add it as my new tag. So we can create tags sort of in any way that you want to. You create as many tags as you want, call them whatever you want, and attach them to objects like this. So it's another way for the game to recognize what your object is. So you can have, you can search for things by name and sort of other ways, but tags is one of the ways that you can do it. So now when I run, it should run just fine. So there's no error anymore because I've set up the tags correctly. Now I can find the game object. The other potential way that I could do this, let me get rid of these references here. There are these calls to finding the tags, the stuff with the tags. If I made this public, so a public player and a public spawner, I can go back to Unity. And in my game manager object, the one that has the script attached to it, notice it has two places. It has a place for a player and a place for a spawner. Well, I can just grab my player object and drag it in here. And I can grab my spawner object and drag that in there too. So when I run now, it works just fine too. This works in our situation. But let's say, for instance, I wanted a reference to a fireball as well in my game manager, just a reference to a fireball. If I made a fireball variable in here, where's a fireball that I can grab from? I don't have a fireball in my scene that I can click and drag into. I have the prefab. Let's come over here. Let's make a public enemy enemy. So let that recompile. So I have this enemy now, but I don't have an enemy to actually drag in from the hierarchy. The only enemy I have is a prefab. I can throw that in and potentially use it as a prefab. But if I have something specific, like a player, that is not a prefab, potentially you're not going to be able to put it in one of these spaces. So you do want to be careful using it like this. You may not always be able to put a specific object in here that you might want. This is fine for a prefab, but it's only ever going to spawn this. It's only ever going to deal with the prefab itself, not the individual instance. Here I have an instance of a player and an instance of a spawner. The game manager will use those as their instances. This it's going to consider to be a prefab, not actually an instance of an object. So there is some differences between putting prefabs in here and putting other actual objects that are already in the hierarchy. So that's something to consider when you're messing around with this sort of style. Either way works. It doesn't matter to me. Our game is simple enough to where you're not going to have any performance implications related to this. So I might just leave it this way. But either way works. Just know that you can find game objects in your scene based on things like their tag, for instance, or in some cases their name or stuff like that. Or you should be able to find them based on components as well. You should be able to look at all the various find things. If we do like a game object find, there's tons of them. Find, let's see, game objects with tag, find of type, find of type all, find of type including assets, find with tag, find scene objects. So there's all sorts of finds that you can use here with the autocompletes. There is a difference between, so you saw the find object, the find game object. If you use one with an S, it returns an array. So that's something to be aware of as well. It's find game objects with tag. It will return an array of them. All right, so we're just about done for today. So here I sort of show, the next few slides are just showing, okay, how do you add tags in? Where are the tags? All that kind of stuff. We'll skip over damage for the moment. We might just do that next week. But essentially, we're going to write a function in the player class that reduces the health value. And we'll set the game object active to false. So we'll look at that likely next time. And then that's basically it. So we'll deal with damage before we get into the Unity particle system stuff next time, so that won't take too long. We have 2 lectures on the Unity particle system. So Tuesday will be using the standard particle system. Thursday will be the VFX graph. I did have an older computer that I was running this stuff on, and the VFX graph would actually cause that computer to crash. So as long as you sort of have a somewhat recent computer, I would imagine the computers you got for your school stuff would probably be fine. Or if you have a regular desktop you do gaming and stuff on, it was a Mac without a dedicated graphics card is what I was using it on, like a Mac from like 2014, and VFX graph would cause it to crash. The first GDD, like I mentioned, is available, so work on that with your group. If you have questions about that, definitely let me know. I do have office hours tomorrow from 1 to 2, so you can definitely stop by there if you want to ask some other questions. Otherwise, have a good weekend, and I will see you guys next Tuesday.
Hey, Professor.
Yep.
How'd you make the prefabs tab with the enemy on there?
Yes, go back here. So the sort of the first thing I did was do the normal sort of create empty, call it enemy. I'm going to call this one enemy 1 since I already have a prefab called enemy. And then I sort of added all the rest of the stuff to it. So I put my script, I added my enemy script to it. And I added the graphic to it so I create another empty. Maybe this is enemy graphic. Something like this. Made that a child. So I basically built up the whole enemy in the hierarchy itself. Mm-hmm. And then in the assets, I created a new folder just called prefabs. And you can take this and you can just drag it into the folder itself. That creates the prefab.
Okay.
Yep. So it'll just be a generic thing that you can spawn sort of any way you want to. You can set up the values in your scripts to be whatever you want them to be, and it will spawn with all of the appropriate stuff that you put in here, whatever values and damage and whatever you got to do.
Okay.
So in principle, you can make anything a prefab here. We can make the left and right wall a prefab, and have them spawn them in other places if we want to, or easily spawn them at the edges of our screen if we change resolution or something like that. So yeah, basically anything you can make to be a prefab, but you just drag it from the hierarchy into an asset folder. And it should get this sort of bluish thing. If it has a graphic on it, it'll show the graphic. But up here on the top, it'll say prefab asset.
Okay. All right. Thank you.
Hey,
Oh, sorry.
sorry, I'll be real quick. Just above my variables, like my global variables and things, I don't have the reference thing that you have. Like above my classes, it'll say 0 references or whatever.
Okay.
But like, is that just something to do with the specific inspector you use, or is there something I can do real quick?
I forget where the settings for this are. Originally, I didn't like having it. It's just one of the Visual Studio Code things.
Yeah.
It after using it for a little bit, I did find it kind of useful because it sort of lets me know that, hey, I'm actually using this thing for something.
Mm-hmm.
You're never going to see it on stuff like, you're never going to see any more than 0 references on things like start, because that's not how it works.
Right.
But as far as getting it to show up, it is one of the settings. And let me see if I don't remember if this is in my. Actually, we want the JSON one, because I think that's where I put this. Okay. Let's go. Do I have it in here? Yeah. I guess it's not. So it's got all the Unity stuff in here. Yeah, I don't see anything specific in this one, so it is probably a user setting thing. I'd have to mess around with it a little bit to remember where this is. You can
Alright.
probably look it up.
Yeah, no big deal. I can just look it up after class. I think there are other people with questions.
Yeah, because it is just one of these settings to include. I just don't remember where it is.
All right, sounds good. Thank you. Have a good one.
Professor, for my question, when I go back to Unity, I'm seeing that player could not be found. Player does not contain a definition for reset, and no accessible method or accessible extension method for reset.
Go ahead and share your screen real quick.
Okay.
I think, let me check. I think you can do that because I think I didn't set it back before.
I think you might have to stop sharing. Oh, there we go.
Yeah, you should be able to.
Alright. Can you see?